And we are not going to do A here today. Although A is a worthy question, it's not as pertinent to what we're working on right now. B, C, and D are. So we're going to start off with question B once you've had a chance to read. Okay, how would you describe what's happening here? Water in, water out. Sorry, it's a tank, there's some water flowing in, there's water flowing out. Basically, right? So it's the proverbial water tank question. All right, so then dig a little deeper on the details. What kind of a thing is W of T? That's right. So yeah, remember whenever we're working on these word problems, we're going to try to identify any rates that are important. So W of T is certainly a rate. And so there we go. And what about R of T? Is R of T also a rate, or is that something else? It is, yeah. So we've got our two rates right here. You can tell by the units. You can tell by the fact that it says the word rate. Pretty important. So we want to really kind of key in on those rates. Is there anything else that kind of jumps out to you from a math perspective that you feel like, yeah, you know, this might matter when I work some of these questions? You see anything else? Say again? Yeah, the interval from 0 to 18. Yeah, that's the initial amount, right? And so as we start to pick this apart and say, well, this is really important. Hey, there's a rate. Those are usually important. We want to make sure that we're marking the question up. So then we get to B. Let's read B here. It says, to the nearest whole number, how many gallons of water are in the tank at time t equals 18? I feel like there are 2, maybe 3 words in this question that tell you exactly what to do. What do you think those 2 or 3 words are? How many gallons? So when you see that kind of wording right there, what are we talking about? What sort of thing is that? But it's not position in time. It's an amount, right? It's an amount of gallons. It's not a rate of anything. It's simply an amount of gallons. So maybe as you mark this question up, maybe you write that and you say, hey, we're looking for the amount of gallons. We're not looking for a rate of change of gallons in B. We're looking for an amount of gallons. And that should give you a pretty large hint about, given the things that you were given, and given that what we're supposed to find, what we're supposed to do. So let me give you a couple of minutes to try to explore this. This is definitely a calculator active question, without a doubt. And so if you would, I think the calculator will be a key feature when you're working on part B. So please do get that out. See if you can set this up, and if you can take it all the way through and actually answer the question too, that'd be great. Give it a try. Let's talk about this from a setup perspective. This is asking for how many gallons. Hey, listen up. Asking for how many gallons of water are in the tank at time t equals 18. The fact that they're asking you this question, doesn't it probably mean that the amount of gallons is changing over time? Right? At t equals 14, maybe it's different than when it's t equals 18. When it's t equals 8, maybe there's a different number of gallons than when there's t equals 18. The amount is changing, right? Why is the amount changing? Why would the amount of water in this tank be changing?
Because it has an input and an output.
There's an input and an output, and the input and output are...
Different.
Say again, Ben?
It's different.
They're different. So counteractive is not a really great description, because if the rate in was like 10 gallons per minute and the rate out was 10 gallons per minute, would the amount be changing? Are you listening to me? If the rate in was 10 gallons per minute and the rate out was 10 gallons per minute, the amount of water in the tank, wouldn't it be staying perfectly level? Yes. But the rates are different, right? Yeah, there's obviously some wave to these rates, right? Because they're both sines and cosines. They're both sines, right? So the rates are different, and so the amount of water in the tank is going to go up, and then it's going to go down, and then up, and whatever, right? Okay, so then we got to consider basically this concept. The amount of water in a tank is going to be how much there was to begin with, which was how much? 1,200 gallons to begin with, plus however much the amount changed. So it's 1,200 plus whatever the change is. How do you find the net change in the amount of something? Yeah, the definite integral of a what? The amount of change will be found by doing the definite integral of what kind of thing? I can't quite hear you. Come on, this is fundamental. You got to know this. Say again? Too generic. The net amount of change, right? So I'm talking about this right here. The net amount of change can be calculated by doing the definite integral of what sort of thing? The function is too generic. Rate. I didn't hear you very well. Sometimes you guys talk real quiet, or maybe my hearing is not as good as it used to be. Say again? Okay. Good, at least good enough. So, my guys here, this is fundamental, right? This is so huge. So let's just go through this again. The definite integral of a rate will give you the net amount of change. This is our focus from last time. It's our focus for this time too. It's called the net change theorem. The definite integral of a rate will give you the net amount of change. So, I've got the original amount is 1,200 plus the change. I got to be a little bit more specific. The change would be the definite integral from 0 to 18. I choose, why would I choose 0? Like, why would that be one of the two limits on my integral? And when t equals 0, the amount is 1,200. So these two things should go together. The 0 should match up with the 1,200. They should go together, right? And then why on earth would I pick the 18 for my other limit of integration? That's what I want to find out. I want to find out how much water is there when t equals 18. So one of them should always be, one of the limits should always be something that I know, like in this case the 1,200, and the other one should be the thing that I want to know. Okay. And then we're going to be doing the definite integral of a rate. The problem is we got two different rates, right? We got a rate that's causing the water to increase and a rate that's causing the water to decrease. What do I do? Yeah, the one that causes increase minus the one that causes decrease. So water is pumped into the tank at W of t and removed at R of t. So we're going to say W of t minus R of t, and then of course times dt. Okay, so that's your setup. That's what you would strive to put into the calculator. 1,200 plus that definite integral from 0 to 18 of the net rate. So this is going to finish relatively easy, right? We're going to use Math 9 here in a second. So I want to pause and ask you, do you have any questions about why that is? Any details, concepts? What can I do to help? If there's any confusion or questions, be happy to answer. So Addie, a few minutes ago you were like, I am lost. Are you found? Do you have any questions? Okay. Well, if a question comes up.
I just didn't really know how to start it.
Were you here last time? No, yes? No? Have you watched the video from when you were gone? Okay. Go back and check it out. Well, in any case, I don't remember. But if a question comes up, definitely let me know. Okay. So has anybody done Math 9 with this and gotten an answer? Would you get a chance?
110, maybe. That's what I did, right?
So is approximately, we rounded to the nearest gallon. Do you guys get 110? Oh, the definite integral is
110.
positive 110 or negative 110?
Positive.
Okay, so if you had 1,200 to that, wouldn't you get 1310?
Yes.
Okay, so 1310. What kind of units would go with that 1,310? Gallons, right? That's an amount of water is gallons. Okay, so guys, the big concept, the concept that we applied last time with that triangle-y looking graph, the concept we're applying here is simply this. The net amount of change is equivalent to the definite integral of the rate of change. That's the concept. We'll do some more with that here in a second. All right. Any other questions, concerns? Bring it up now or later. I don't really care. Here's a chance to bring it up. All right, fair enough. So then part C. Part C says, at what time t on that interval, it looks like the closed interval is going to matter here, is the amount of water in the tank at an absolute minimum? Show the work that leads to your conclusion. Okay. So for those that remember from last time, if you guys remember the triangle-looking graph back here, this is going to maybe remind you of this a little bit, okay? So let me remind you of a couple things and let you try it, okay? So we're clearly looking for an absolute minimum. What are your candidates for absolute minimums? Critical numbers and endpoints, right? So let's list these out. Candidates are critical numbers and endpoints. Okay, so then my candidates would be times, and my outputs would be the amount. I'll just put amount. Just going to compare the amounts, right? See which one's lowest, essentially is what we're doing. Okay, so candidates that are endpoints, pretty easy. 0, 18. Not particularly difficult. What about critical points? How on earth could we find critical points? Differentiate what?
The rates.
Differentiate the rates?
Yeah.
Yeah, I think we need to be really careful about differentiating the rates that we're given, because aren't those rates of change the rates of change of the amount? And if I were to differentiate those again, it'd almost be like I was trying to find the minimum rate instead of the minimum amount. This is one of those tricky ones where the derivatives have already been done for us. We just need to recognize that those are our derivatives. So then there are two of them, right? There's W of t and R of t. Those are both rates of change of the amount. How do I put those together to help me find my critical points? So, okay, so subtract them. So like we did before, W of t minus R of t. That's our net rate, right? Because W is making the amount increase, R makes the amount decrease. Okay. What do we do with that, though? We're looking for critical points. Set equal to 0. That's right. Okay, so then the other big question is, like when you realize what W and R actually are, that's a really complicated equation, right? Insanely complicated. How are you supposed to solve it? Please, for goodness sake, use your calculator, right? Graph them, find the intersection point, or find the 0. Probably the way that it's written, use the 0 finder would be the better way to go.
Man, this is even a pain to put into your calculator.
I know. Isabel, any questions?
Yeah.
Doing good?
It's really
Okay.
hard.
You have a calculator with you? Okay, well, let's practice using the calculator. If I were you, I'd make my windows 0 to 18, simply because we don't really care about anything outside of that. If you make your window 0 to 18, you should be able to find the critical number or numbers that show up. You have one?
Anything wrong?
Oh, this is my grade, so it should go through. But it should cross through.
Did you put in W of t minus R of t? Yeah, definitely. There's potential for positive, negative values here. I would adjust your window so you can see what's going on underneath, just to be for sure.
Is there any way to like copy and paste
I don't know. Can you guys copy and
equation?
paste off of the screen? I've never done that. I usually enter mine into like Y1, Y2, just so I can reuse those.
Oh, okay.
Or I don't know. Here.
Plug Y1
Just
or
hit enter.
Y2 into like into math.
Here you go. Store, alpha, trace, Y1. Enter.
And then
Oh, it won't let us do that. Darn it.
okay.
Hey, this Dan's question actually brings up a pretty good point. If you're ever working on some question like this and you take a quick glance through and you realize, I'm going to be using these rates more than once and maybe even in different ways, kind of like this one, that would be, to me, a clear signal to put your rates into like Y1 and Y2 or just Y1 or whatever. That way you don't have to like re-enter them over and over and over. You just enter them in the Y1, Y2, whatever, once, and then use them. To me, that would make sense. especially if you're going to use them more than once. If you're only going to use them once, it doesn't really make any difference.
What will you do?
Yeah, okay. So you need to times,
Did I write it wrong?
so it's not times anything. Oh man, you're entering it really badly. Oh, darn it. Okay.
Then square the sign.
Okay, so
No, you have to do
so this,
sign it first.
there is no multiplication happening right there at all.
You can just do second.
It is not sine squared. Yeah, the input is t
Yeah.
over 6. So you need to, here, I'll just compare here. You've got to enter this as 95 root x parentheses sine of x over 6 squared,
Got it.
right?
I like-
Has to be entered
Yeah.
that way.
Okay.
The other one's not good either because you're squaring the input instead of the output. Use the zero finder. I have no idea.
75.
Okay, you've entered it right. What's your window? I'd go 0 to 18, and I would say
How many did you get?
How many did you get?
One.
I got 1 right there, 2 right there. Yep, looks like it's done. You are in radian mode, so that makes sense. And you're asking what you do now? Use your zero finder. Yeah. Second calc zero finder. Ben, what are you seeing?
Oh no.
Okay, 95 root x. Okay, you put a plus sign in there. Should be times.
Oh, yeah, that'll do it.
Am I taking the derivative of this or is this my derivative?
Addie, those are your 2 rates of change of the water in the tank.
So it is my derivative.
That's your derivative of the amount.
So this is my minimum.
So that's it. So Addie, be super duper careful. We're looking for candidates right here. We have to consider endpoints. You can't say, hey, look, the rate of change goes from negative to positive. Done. You have to consider endpoints.
Wasn't the kid you wrestled?
Okay, Ben.
He was fourth. How much did
Okay.
you win? 12 pounds heavier than me. How much did you win?
Oh,
Were you
okay.
winning?
You entered them 2 separate graphs.
Because I was like,
I think it's best to enter them as a difference between the 2 graphs. So what I'm going to do is I'm going to go alpha trace.
I hope we
Stop.
make it this day because I didn't want
I'm going to go
the big no.
alpha trace. What is it
No,
doing?
I was sick.
Variables, I think you have the old one. Minus
Was your dude good? Was your dude?
variables, y variables, 2. I want to graph y3.
Okay.
They made me wait.
Y3 is going to show me the graph of the net change. Okay, guys. Hey, listen. We gotta get the calculator stuff squared away right now. I don't have time to individually help everyone with their calculators. How are we doing? We gotta be absolutely locked in on the calculator using the zero finder, the graphing piece, everything. We gotta be locked in. Are we doing okay? Okay. So have you found the zeros? 2 of them, right? 6.495 and 12.975. Okay. We get any agreement? Those look reasonable. We agree on those? Okay. Okay, fair enough. So then we put these into our table, 6.495 and 12.975. Okay, so we're finding an absolute minimum here. The good news is of my 4 candidates, I already know 2 of them. I already know the amount at 2 of them. What are the 2 that we know? 0 and 18. When t equals 0, the amount is 1,200. When t equals 18, we already found the amount is roughly 1,310. What about those those two critical points? How could we find the amount of water in the tank at those points? Ooh, okay, now one at a time. One at a time. You said plug them into the net rate. If I plug those into the net rate, what should I get?
The net rate.
What number?
Would you get like
If I don't get 0, I messed up, didn't I? Didn't those two numbers come from setting the net rate equal to 0? So I'm not looking to find the value of a rate. I'm looking to find the amount of water, right? Because I'm comparing 1,200 gallons to 1,310 gallons to whatever those other two.
Wouldn't you set the integral from 0 to that critical number?
Oh, is that what you guys were thinking? Use the net change theorem. So let's start there. So if I would say integral from 0 to 6.495 of the net rate, if that's all I wrote right there, so the thing right here in the red box, if that's all I wrote, what would be the meaning of the number that comes out of that?
That's the net rate.
That's not the amount, that's the
Net rate.
it's not the net rate of anything. That's not the rate of anything. It's not a it's
That amount changed.
it's the amount of change from 1,200. Do you guys see why this is so crucial? Remember at the start of the year I told you in calculus we basically cover two things, but we go really deep. Do you see what I'm talking about? Like if you're like unaware of what the number means, you've missed the boat. It can't just be like, hey, I got some number and frankly I don't know what it means. That's a major problem, right? And so that's why I'm asking you these questions. So the result of this is definitely the amount of change. Do I want to finish with the amount of change? What do I want to finish with?
The amount of change plus 1,200.
The amount of change plus 1,200. So I'm going to take this and I'm going to go plus 1,200. And when I calculate all of that, and I'm putting a box around right here, I use Math 9, of course, the result of that will give me the amount of water at that first critical point. Make sense? Okay. So can you guys do that real quick? Yes? No? Please do. Please do. Were you going to say the 1,200?
Oh, no, I just had a question. I understand.
Okay. Addie, are you getting better?
This part made sense. I've just been completely lost this whole unit, I feel like.
So I would be willing to bet. Okay, so did anybody have that yet?
Yeah. 1697.
Say it one more time.
1697.441.
Okay, so that's a max, 441. That's actually the maximum, right? Okay. So what you would do here, now that you have your table all the way filled out, all you really have to do now is pick out the lowest output because we're looking for the minimum, and just name it. So all you got to have to really say here now is the minimum. It wants to know at what time the minimum happens. So we're going to say the minimum happens at t equals 6.495 hours or whatever. It doesn't make us put units here, but whatever. Okay. What do you think? So look back really quick at the triangles. Do you see how the triangle graph that we did the other day, do you see how it was really a similar concept? It's initial amount plus the change gives you the final amount. This was just more of a contextual question. The last one I really like for you guys to look at as well. It's kind of hard to see. I'll adjust the screen here in a second. It says, listen very carefully, for t greater than 18. So we're now outside of that original domain, right? So for t greater than 18, no water is pumped into the tank. So W of t turns off, stops, whatever. But water continues to be removed at that same R of t rate until the tank becomes empty. Let K be that time at which the tank becomes empty. Write, but do not solve an equation involving an integral that you could use to find the value of K. Okay? So again, I want to help you interpret this. Starting at t equals 18, W turns off. Right? So there's no more water coming into the tank, but whatever was causing the tank the leak or the water to be removed continues on. Obviously, at some point in the future, the tank's going to be empty. We're trying to set up an equation that, if solved, would allow us to find when that time is. Okay? Take a few minutes, think it over. We're just looking to set something up. Add to your question. That's fine. Longer than I thought. So we're about 5 or 8 minutes behind where I thought we were going to be. Let me do a little bit of thinking here. Okay, so let's do this real quick. Let's go back here and let's practice doing a little bit of writing. And so the writing here is simply going to be explaining the meaning of things. We've done this before, but maybe not quite in this context. So the top one, writing example number 1, says Paul's TVs sells TVs at a rate of R of T, TV per hour. Using correct units, explain the meaning of that. You've seen this before. Oh, no. This is where you write, not talk. Practice writing. Practice writing. This is one of those things, like, have you ever been to a place where, like, everything, like, sounds real good up here in your head, and then later on you have to, like, write it out, and you're like, it doesn't sound very good anymore? So this is why I want you to practice writing it. Because if it's going to sound bad, I want it to sound bad today so that you can start to process and get a little bit better. Right. There we go. Yes, ma'am. Okay. We're going to go with a chain function. Oh, you mean like a composite? When does that come up? Shouldn't have. We're going to look at that next week. We're going to look at how to do that. It should be doable without. There might have been some algebra that you could do to get it out of that form. Was it like was it something like, I don't know, 3x plus 1 to the second? What is that? Like, go ahead and expand. Like 3x plus 1 squared just means 3x plus 1 times 3x plus 1. Let's go ahead and multiply it out. Later on, like, of course, my idea is terrible if it's 3x plus 1 to the 100. Right? So we'll look at a separate strategy for those sorts of cases. Jay, question?
Is this
The average, ooh, it's, this one is a little bit tricky. That 1/12 is pretty important.
Did you say the average number of TVs he sells in 12 hours? Is that what you said? That's what I
It should
thought.
be from 0 to 12. Is that what that says?
Is this?
0 to 12, yeah, 0 hours to 12 hours. Yeah. Okay. Can I show you a really generic, this would probably get you by okay, but this is going to be the least contextual, and so of the good answers, this would maybe probably be the worst good answer, if you will. So here we go. I would say that this means, I'll say that this is the average value of R of t. Does that make sense so far? You see that average value expression? So average value of R of t measured in what? Yeah, R of t is measured in TVs per hour. So this would be in TVs per hour from t equals 0 hours to t equals 12 hours. So look at that for a second. What do you think? It's the average value of R of t. Please keep in mind, I'll use a different color here. We We looked at this formula over the course of a couple of different days. Hold on. Doesn't that right there, doesn't that give you the average value of whatever is in there? It does. Whatever that is, maybe what's in the red circle there, maybe it's an amount. That would give you an average amount. Whatever's in the red circle, maybe it's a rate. So this would give you the average rate. This formula, 1 over b minus a times the integral from a to b of whatever, that'll give you the average value of whatever the integrand is. Yes?
So it's not the average number of TVs.
So let's get a little more specific and let's talk about that. So if I was going to do a really great job at this, I'd be contextual and I would say 1/12 integral from 0 to 12 of r of t dt is the average rate of change of TVs in TVs per hour from t equals 0 hours to t equals 12 hours. What people tend to do here is they tend to ignore the importance of the 1/12. They look at the 1/12 as just, it's just some coefficient. Oh, the 1/12 makes all the difference as far as what this means, right? The 1/12, let me put it like this. If the 1/12 wasn't there, if it was just the integral from 0 to 12 of r of t, it would actually end up being some kind of an amount, wouldn't it? With the 1/12 there, it's an average rate. Caleb.
If you were just to change like rate for value in the first one, is that correct? Or
No,
do you-
that'd be a
no.
problem. So like if you
Is it
put,
not of R of t.
yep,
Okay.
so if you put rate right here, you'd be telling the average rate of r of t. Well, r of t is already a rate, so it'd be the rate of change of the rate. Now we're talking about something different. Yeah, good question. Others, please speak up. So can I ask a question for you? Maybe you're asking this in your head and you're just not saying anything. Is anybody looking at this and saying, hold on just a second. I thought that the definite integral of a rate was the net amount of change. And now you're telling me it's a rate. Anybody thinking that? Why on earth wouldn't you say it? Why did you make me ask your question for you? Be bold. Like, it's okay to question. You usually have a good answer for you. This is a really good question to ask. And my response is going to center on this. The 1/12. The 1/12 is everything. Okay? So let's think this over. I'll just use the whiteboard here. Okay, so if r of t is a rate, right? Measured in TVs per hour, one of the ways we can do this is we can look strictly at the units. Okay? So check this out. If I have the integral from 0 to 12 of TVs per hour, makes sense? Like that's the units for r of t. And then there's the dt. What are the units on the dt? Hours, right? So isn't it a little tiny sliver of time? dt, tiny change in time. So the units would be hours, right there. So if I think about this, wouldn't the units cancel here? Giving me just TVs. And so I would add up a bunch of like really skinny slices of numbers of TVs. That would give me units of TVs. And wouldn't that indicate that the result is an amount? Like maybe a net change or something, net amount of change? So I totally get why somebody would be like, no, I think it's the average amount. But here's the thing you're missing. The 1/12. We still haven't considered it. There are units on the 1/12. Do you know what they are? Close. Real close. There's no units on the 1.
Per hour.
But there are units on the denominator per hour. Right? So with that, our units are 1 over hours. 1 over hours times TVs gives us TVs per hour, meaning that the result is some kind of a rate, specifically an average rate. Does that make sense? No? Yes? Okay. Units will always tell the full story. They're not always easy to deal with, They'll always tell the whole story. Okay. So then, if you haven't already looked at the next one, the one about the number of eagles in a wildlife preserve, please check that one out. Number of eagles in a wildlife preserve is modeled by E of t, where t is time in days. Using correct units, explain the meaning of the integral from 0 to 31 of e prime of t dt. Yeah, it's very different than if it was an e, right? So E stands for the number of eagles. I want you to discuss what is the meaning of the integral from 0 to 31 of E prime.
How is it an average value?
It's the average?
If it's a rate, then how is it an average?
It's the average value of R of t, and what kind of thing is R of t?
So, but if we're finding, if the end result is the average value.
The end result is the average value of something, and the of something is crucial. If I told you that it was the average value of the amount of TVs, that's very different than saying the average value of the rate.
Oh, so you're saying average rate.
The average value of the rate is the average rate.
Okay, I think I did.
Like I put up there, I put it's the average value of R of t, which would beg the question, right? Well, what kind of thing is R of t? It's a rate.
Okay, so it's not really finding what's here. It's not really going from rate to amount. It's just rate. Average rate.
If you want to like look at all the little tiny steps, like when you first do the integral, the definite integral of a rate is still a net amount of change. But then when you multiply by the 1/12, that's what turns it back into a rate.
Kind of going. Okay.
That make sense?
Yeah.
Here's another way to look at it. To look at it a little more generically. So would you agree with me that f prime would be the rate of change of f? So check this out. Does that make sense? I replace this whole integral with ftc1. The antiderivative of a f prime is just f. And then if you think about it, like we just rearrange this a little bit, f of 12 minus f of 0 over 12. Isn't that an average rate? Isn't that so what the secant line?
Yeah, that's how I know.
It's the average rate of the amount. The average rate of change of the amount, which means the average rate.
And that's just the derivative.
Yeah, you put the limit out the front. It's the average. It's an average slope.
Oh.
And you get an average rate of change.
Gotcha. Okay, that's that.
Okay. All right. So I am thinking, you wouldn't have to do this, but I'm thinking with this Eagles question that if you did just a smidge, just a little bit of math, it might actually help you explain what this means. So what if you did this? You wouldn't have to do it this way, but I'm just saying what if you did. Might be helpful. So integral from 0 to 31 of e prime of t dt. First of all, how does the antiderivative interact with that prime? Cancels out. So I would say that this equals e of t evaluated from 0 to 31, or better yet, how about e of 31 minus e of 0? Does that make sense? You're going to do an FTC 1 and 2 there, right? The antiderivative cancels out with the derivative. You subtract the difference in the evaluations. Okay. So really it comes down to what is the meaning of this? I'd say something like this. Integral from 0 to 31 of e prime of t dt is the net change of the number of eagles from t equals 0 days to t equals 31 days. It's the net amount of change. Net change of the number of eagles. Again, guys, the principle holds. The definite integral of a rate, which is what e prime is, right? The definite integral of a rate is the net amount of change of whatever we're talking about. In this case, it's the number of eagles. Okay. Addie, you're not allowed to make the scrunchy up face and not say anything. She was like, what? Come on. Goes for everyone. No scrunchy up faces with no questions.
Can you explain, please, why it's the net change of the amount instead of the rate like above?
Okay, so you know what it all comes down to? There is one difference between these two expressions, and I'll highlight it for you. The 1/12.
Yeah.
Right? So the 1/12, as far as the meaning goes, makes all the difference in the world. So, okay, so let me put it like this. To compare these two. The integral from 0 to 12 of r of t dt, we're going back to the TV questions. That right there, that definite integral, guys, the meaning of that, this is the net change in the number or the amount of TVs. Now, it's the average rate of change of the number of TVs. With the Eagles question, the Eagles question was simply 0 to 31 of E prime. There was no 1 over 31 out front. If there was a 1 over 31 right here, it'd be exactly like the TV question.
Because doesn't E prime kind of make it like that almost?
Yes, E prime is definitely a rate, but the definite integral of a rate is the net amount of change. Just like over here, like if you look at them like this, E prime is a rate, R is a rate. Conceptually, these are identical. Conceptually, now they're different. Oh,
So if they're conceptually the same, then what is the E prime do? Why does that make it, like, how would that be?
go say it again.
So if they're conceptually the same, then what is the E prime?
So it's all about how they're defined, right? So if you read the way they're defined, it says, in the first one it says, Pulse TV sells TVs at a rate of R of T. So it's defining R of T to be a rate. R of T is the rate. That's just how it was defined for us. In the Eagles question, it says the number of Eagles is modeled by E of T. So you're given two different categories of function. R of T is classified, just whoever wrote the question, I guess it was me probably, classified R of T as a rate. It said, hey, this is a rate. E was classified as an amount, therefore E prime would be the rate of that amount, the rate change. Okay. Yeah. Other questions? Yes, sir.
Is this regular E of T?
Yeah.
Would it just be the amount of eagles?
No, because the antiderivative of the amount of eagles wouldn't just be eagles, right?
So it would be time?
It would be, yeah, actually, it'd be eagle days.
What?
What?
What are the units on E of T? What are the units on E of T?
Eagles a day.
No. The units on E of T are simply number of eagles.
Yeah.
And what are the units on DT? Days. What's eagles times days? Eagle days. Eagles times days. Which could conceivably have a meaning.
So,
I don't think we'll go there.
so the one we just did.
Wait, what? That doesn't make sense.
So how do you get the amount of eagles?
How do you
Because
amount of equals
this is E prime.
times
So isn't that giving you the amount of eagles between 0 and
It's the net, that's what I wrote.
Yeah, okay.
It's the net change of the number of eagles from T equals 0 to T equals 31 days.
Okay.
Because E of T, hey guys, this is probably good for the group, so don't get distracted. If E of T is measured in number of eagles, what are the units for E prime?
Eagles per day.
Eagles per day. And so the net change, or excuse me, the definite integral of a rate gives you the net change of the number of whatever, in this case it's eagles.
But I was confused with this when you said, or if you're taking the integral of just E of T.
Yeah.
How does that go to equal days?
All about units. And Addie, I mean, this might be a worthwhile discussion, but the truth is, like, I don't think we're ever going to really get to go here. What are the units on E of T?
Just equals.
Number of eagles or amount of eagles, right? What are the units on DT?
Time over days.
No, it's not time over anything. DT is a little tiny sliver of time, measured in days, I think.
Yeah.
So it would be eagles times days.
Oh.
What does that mean? I don't know exactly. So we probably won't go there.
I thought you were saying it was eagles over days.
No. Eagle. I said eagle days,
Hours divided.
not per. Per would be the important word for sure. Yeah. All right. Okay, it's a good discussion. So here's what we're going to do. I really want to get your loop quizzes back to you. I never know how these classes are going to go as far as timing goes. Hold on though. I got to show you.